Welcome to Module 3. We are going over lessons 1 and 2, which are over rational functions. Now, your homework splits this up into 2 different lessons. So we're going over this one lesson, rational functions. You have 2 homework assignments over it. They call lesson 1 basic, and basic has no holes or oblique asymptotes. And you'll understand what this means a little bit more when we get into our lesson. So then advanced is going to have a lot of holes and a lot of oblique asymptotes. And so that's kind of the difference, but it's all under the umbrella of rational functions. So I'm just going to teach this as one lesson. To prepare for this lesson, you need to be able to state the domain and range from a graph, which was module 1, lesson 4. You need to be able to factor and solve quadratic equations, which was module 2, lesson 3. And then you need to be able to use polynomial division, both synthetic and long division, from module 2, lesson 7. Our learning objectives is to find the domain and holes of a rational function, to determine vertical, horizontal, and oblique asymptotes of a rational function, to find your x and y intercepts of a rational function, and then to graph your rational functions. I'm assuming you've already used this QR code, so welcome to the lesson. As a reminder, you can pause and rewind as often as you need. So this lesson is literally at your own pace. And then you need to look at your schedule to see when this lesson's homework is due. We're going to go ahead and jump into this lesson. In this intro video here, I want to go over what a rational function is, and then we will start going over some of our learning objectives in the following videos. So the first thing we're going to do is first define what a rational function is. And a rational function is a function in the form of r of x equals p of x over q of x, where q of x cannot equal 0. So that p of x is some polynomial, which is how we ended module 2, divided by another polynomial. So you're going to have x's in the top and x's in the bottom. So in module 2, lesson 1, we went over key graphs. Can you remember which key graph this is? Pause it if you want a little bit more time to either look back at your notes or think about it. This was your reciprocal function. And your reciprocal function was f of x equals 1 over x. So this is your most basic form of a rational function. I have a polynomial on the top. So usually we'll have more x's, but it could just be a number. But the big thing is we're also going to be dividing by variables. So all over x. And so when that happens, my graph are these 2 blue lines right here, kind of going in opposite directions. Now we have these imaginary red lines. We should kind of recognize those. We had imaginary lines when we did quadratics as the axis of symmetry. These dashed lines represent our asymptotes in this graph. So what is an asymptote? In analytical geometry, an asymptote of a curve is a line such that the distance between the curve and the line approaches 0 as one or both of the x or y coordinates tends to infinity. So as this graph is going up, it's going to get closer and closer to this vertical asymptote, which is at x equals 0. And as this y coordinate tends to negative infinity, it's going to get closer and closer to that asymptote, but it's never going to touch it. It's never going to cross it. And then we have this asymptote right here. And as this x goes to infinity, it's going to get closer and closer to this horizontal asymptote at y equals 0. And as this goes, as the x here goes to negative infinity, it's going to get closer and closer to that horizontal asymptote. So this is your most basic rational function. But down here, we have some more examples of what they can look like. So this is literally this one right here just shifted, right? Now it has shifted 2 units to the right and 1 unit up. But these all look completely different from that basic function. So you can have this where it approaches like how they're both going up rather than kind of being an opposite right here. They're both going up. This one only has a vertical asymptote. It has, oh, no, it does. I see horizontal asymptotes right here. This one has no vertical, no horizontal, but it does have, this is your oblique or your slant asymptote. You can have more than just these two sections, how we have up here. You can have 3 different sections. You can have more than that as well. So there's not really a one shape. Most of ours are probably going to look like this right here in some capacity, but they can look and take on many different forms.